Let's talk about CI. Why is CI so important? So when you ship quality software, you want to be sure that you catch all the bugs ahead of time. So a really good CI is essential to make sure that you catch everything as soon as you can, and you do it in like a really fast way. So having a good CI experience is really important for a day-to-day development. And mobile CI is not like a new problem. There's a lot of solutions out there in open source. There's Circle CI, Travis, and Jenkins on Android. I'm sure a lot of you folks use any of this. Anyone using anything else outside of these things? I can barely see. Right. I'm assuming that people use a variant of these three or something that's home-baked. Right. So this is like a solved problem already, but why are we talking about this today? It turns out, actually, Android CI at scale is a completely different beast. When you have hundreds of developers contributing to a code base as large as we have at Uber, we have a large monorepo of Android apps. There are several apps. There's hundreds of developers pushing hundreds of changes on a daily basis. So CI gets pretty tricky at that point of time. And there's a lot of things we need to do to ensure people are still getting builds fast and they're able to make sense of what the build output is. So we're going to talk about Android CI at scale. But first, a little bit of history on how CI evolved at Uber. So I joined Uber about a little over 4 years ago. There was no CI when I started. We didn't even have unit tests, I believe. So there was not really a need for CI as long as you made sure you built your app, and it worked. So eventually, what happened was we had one simple app. So creating a CI was actually not that difficult. We had one box on an engineer's desk, a simple Mac Mini that was running Jenkins. How many folks have a CI like this today? I'm just curious. Oh, there's quite a few actually still. So this might be the start of your journey as well. So you could maybe glean some insight into how ours went. We had one Jenkins box, which was running on a Mac Mini. I don't know why we didn't choose Linux at the point of time, but I guess we were using it both for iOS and Android. And it was powerful enough to like run our builds. And this is how our CI workflow looked like. We would have code on our laptop, and we use this code review system from Facebook called Fabricator. We would push a diff, which is equivalent to a PR in the GitHub world, and it would do some sort of local validation to ensure that all your lints or some sort of code style formatting is correct. And it would go to the code review system, and then we would kick off the CI job that would do things like building, running static analysis, and unit tests. It's very typical, I'm guessing, compared to what all the other folks done as well. Once that's done, the developer receives a signal saying, hey, everything's good, and the developer goes and arc-lands, which is essentially a way of saying git merge, right? And then that goes into the code repo and merges in. Very simple workflow. And then suddenly our code exploded. We had a lot of repos with a lot of code, and that was when things got exciting. We took that one box, and we built many boxes in a giant rack. This is not really like a configuration you can buy, by the way. So no one really sells Mac Minis racked up to put in your data centers. If anyone's worked in DevOps, they'll tell you that there's a large heating issue, especially since the Mac Mini fan is not really powerful enough to like blow out all the heat. So we had to do some clever wiring and other techniques to get this to actually work, put it in its own isolated cage so we could ensure adequate cooling. And this is kind of OK for a while, where we were running a bunch of Jenkins slaves on all these nodes, and we were still doing our builds that way. And that's when some of our problems started. We would have a red master a lot of times. You might be thinking, why would that be the case? Like, don't you test all that stuff on your CI builds? So technically, we do. So assume there's like 2 developers pushing changes to the code base. I mean, 2 is just to simplify. They might be touching different parts of the code, but they might be doing it in a way where the tests might be affected. So once their diffs both say green, even though they're OK individually, the moment they merge onto master, master still can go red. It could be due to merge conflicts, but most often it's also happens due to like test state being like not isolated, or just like broken APIs that the other diff did not expect. Has anyone faced this problem before in their code base? There's a few people. So like this gets worse as you have more number of developers. So in our case, we had a giant monorepo, close to like hundreds of commits every day. So this would be a regular occurrence. So this is from last year. We had, this is measuring our stability of CI. And just seeing the green and red state, you can see there's a lot of dips. This is like unworkable. Like anytime something hits red, we got to revert. And we had a guy called the Bill Sheriff, his job was literally to constantly monitor this stuff. I don't think he works at Uber anymore. I think he quit after this happened. Anyway, so moving on. Gradle was what we were using back in the day. And it was beginning to show its age. It's gotten a lot better over the recent past, but we were at a stage where our builds were really slow. Just because of the large amount of code we were building, thousands of Gradle modules actually in the code base, in the mono repo. So it's a pretty complex code base, and we were seeing really slow builds, which means developers were waiting for CI before they could merge their change and start working on the next thing. This is not that great. LL logs were a mess. You could barely figure out what was going on locally. So imagine CI running all sorts of parallel combinations of tests and builds, and then you get a Jenkins link, and you got to go figure out like what actually went wrong to like fix your build. And this is taking up a lot of our developers' time, and this is not ideal either. So this is like a huge problem as well. And it actually started affecting our release schedule. So we release apps once every week, and we try to like cut releases as often as we can so we can do like sanity testing and alpha, beta, that sort of thing. But we were only cutting like nightly builds because ProGuard was very expensive to run on every single change. Or we would at most be able to cut a build once every few hours at most. And this is really bad for release because typically, I don't know how many folks run ProGuard, but if you do run ProGuard with optimization on, it can take a really long time on CI. So if you do this on every commit, and you have like a large number of commits, eventually you won't be able to like catch up to the number of commits coming in, and you just have to keep adding more hardware. And this is not great because then you can't really test your changes as they land. So we could literally never even dream of doing something like a continuous delivery pipeline where we could take commits coming in and immediately try to test them on an actual release build. This also made it tough because we would catch issues in the ProGuard configuration or release super late into the game that would basically set back some time, and people have to like go fix these things on release builds later on. So let's talk a little bit about the present. So we looked at all these problems, and we asked ourselves, what would be an ideal Android CI experience? Like, what are the defining characteristics that we would want in a system like this? So we want it to be reliable. This is the first and foremost. If it's not reliable, then our developers really can't trust the results that are coming out of it. They expect it to be available all the time. And at the same time, they expect it to be fast. If it's not fast, then you're wasting time just waiting on builds. And we do a lot of that already as developers. So anything we can do to make it fast would be something that we would want to do in our CI as much as we could. And as I talked about trust, how many folks actually trust their CI results these days? Have you ever had that situation where you thought, oh, this worked locally, but the moment it's on CI, it says something else? And then you try to ping someone on the CI team like, hey, I don't know, like, this is completely broken. And they say, no, try again. So like retries are really bad. Like it just frustrates developers. So if the developer can't trust your CI, then they're going to try to do bad things with it. Like they'll just click retry a bunch of times, and we'll end up wasting resources, just hoping one of the builds would be green. So it's not the best situation to be in. So like trust was another important thing we wanted to like build with the developers and our CI. So we started on this journey, and we thought, okay, let's try to see what we can do to improve the situation. So we switched over to Buck as our build system. It gave us like fast builds, it gave us reproducibility, and it gave us like incremental builds. So it was good for the speed aspect. At the same time, we threw some cache at the problem. So we cached all our artifacts on CI, so all our CI builds could like use it across all the different nodes. We took some more cache and threw it at like Linux hardware, and we got like beefy servers with like a lot of CPUs. I don't know why we were building on Mac Mini still then. It just beats me. But finally, someone had the idea, hey, we should try building on Linux because we're not on iOS. So luckily, we had that option. So we had like better hardware to like make our builds go faster. And that improved our build speed quite a bit. So this is a chart showing the various times our CI jobs take on like a weekly basis and which kind of buckets they fall into as they come in. And we're trying to get these numbers up all the time. I don't have charts from before because we were actually not measuring them at that point of time. But luckily, we were measuring now, so I can show you some numbers here. But we have like a lot of builds that are improved, and we actually constantly monitor this to ensure that we're not regressing at all. So this ensures that there is some expected SLO in terms of where your CI build is going to fall in. And this is a system called submit queue that we developed to handle the master red problem. So as we discussed, like when commits can come in, they can compete with each other, and they can cause issues after they merge and cause master to go red. So to combat that, what we have now is we have this new phase that happens after our client called submit queue, which essentially takes the commits as they come in a queue and puts them in that order and starts running the same exact stuff that we ran on the diffs job on submit queue, like the build, lint, unit tests, et cetera. But additionally, we also run UI tests because they're too expensive to run on every single diff. But once it's in submit queue, it's kind of the final golden state that it's going to merge into, so we run UI tests. And since all of these come in order, we can ensure that these things can actually merge without issues. If they have any issues between themselves, we can detect them at that point of time and kick them out of the queue, and the developers can retry. And this solved our master red problem for the most part. So this is the status of the master build after we had submit queue. There are still a few blips, if you can notice, and I'm going to talk about why that is a little bit later on. But for the most part, we didn't need the build sheriff rotation anymore, which is nice. I'm going to take a quick break. Cool. So with the build speed issue kind of mitigated in a way, we started looking at what do our developers actually want from CI. So we started focusing on the developer experience. First problem was logs, as we discussed. No one really likes reading through logs. Does anyone like reading through logs? I don't think so. There's someone who raised their hand. OK, so what we did was we started looking at the logs in a holistic way. We started looking into how we can surface the logs on the code review tool so you actually get the exact error in the context that you actually care about. So for example, if there's a compilation error, we report back inline on the file that caused the issue and tell you exactly why that thing failed. So this is better than having to go figure out on like a large log, especially if you have like many errors. There could be like compilation issues, other things like, for example, lint. Android lint has like a ton of issues that you can report. So we report back lint errors as well, in both like Java code or and also like XML code in this case. So we do this by parsing the log output for all the different various tools that we have. And then we have this API in Fabricator that lets us comment back on the diff with the error that we want to show. So this reduces some of the overhead that the developers have to go through to actually parse error. And for things that don't have inline information like AAPT or Gradle, we just post back a comment that says, here's some relevant piece of the stack trace, and that might help you debug it further. And we kind of categorize these things into different varieties. There's AAPT package, Gradle compile. This is more important for us to track where people are hitting issues so we can improve those flows. Similarly with tests, we started reporting the test failures back on the code review tool. We only report the tests that fail. So you can see both the stack trace and also how long they ran and where the assertion error was, for example. And you can dig into the details if you wanted, so you don't need to go download all the logs from Jenkins. Especially for a large build, which is running a lot of tests, it can take a long time for CI to actually even load. If you work with projects that have or open source projects, for example, on Travis that have a ton of logs, you'll see parsing them, just Travis loading them takes a really long time. So this kind of prevents having to even load those logs. We're just giving you the focus information. This is another thing we did. So tests can fail not just because of assertions, but they could also hang, just poorly written tests, or maybe they're using Roboelectric. So it can happen. And in these cases, we actually comment back saying there are tests that are actually not finished, and you may want to look into disabling them or figuring out why. And at the same time, opportunistically, we ask people to consider improving performance of some slow running tests, because if a test runs for 30 seconds, it's definitely not a unit test. We also report code coverage. This is super useful for reviewers because they can look at code and look at the coverage in line and ask the author of the change to add coverage where appropriate if something's missing. This is really great to ensure that at least the new code that you're adding has coverage where it's important. And it kind of doesn't arbitrarily enforce anything. It's just more on the reviewer and the team to decide like where they would like to actually add coverage. And the other thing that we do is like we give back the repro command. So this is really important because once it fails, how do you actually know that you fixed the problem? You want to try fixing the issue and then actually try to run the same thing again to ensure that your issue was fixed. So we just tell you like you can run this command once you fix the error, and if it's green, then it should be good to like push up a new diff. This is especially useful for like tests that are like deeply nested in some package with like, we'll just give you the filter so you can just run that one test to like fix before pushing it back up again. We do this if there's multiple tests as well, but generally it just helps you like not have to figure out like what to run once you fix. There's some other things we started doing once we knew that we could do like inline code comments. This is not really like something that we do on like diffs, but we have like a lot of code in our mono repo, and code grows to a point where it's hard to like maintain, or there's like duplicate code that gets in, or just dead code people are not cleaning up once the features ship. We do a lot of feature flagging at Uber, and one of the things we noticed is once the feature is fully shipped, there's not much incentive on the developer side to like go clean up that code. So to kind of ease that process, we use static analysis to figure out, after talking to our experimentation platform, that this feature is fully shipped out for n months or n period of time, and then we make a diff automatically with all the places where you added that feature flag, and we remove the else blocks or the if block based on the feature flag, and then we make a diff. And then the user can then take that over, make any changes they want. They can hold off on merging it if they think they want to experiment a little bit more. But now it's easy for them to just press a button and say, OK, this looks good. I can merge this, and I can do like an automated cleanup. So that kind of reduces the friction quite a bit on the developer side. Similarly, duplicate code detection is something we shipped just yesterday, actually. So this thing, what it does is like it uses PMD to figure out like where you're adding new code that might be duplicated in the repo. This way, at least, we can prevent code from growing at an exponential rate and help people like refactor their code and start thinking about modelization. So after all the failures that we get from CI, we start tracking all of them as well. So we started looking at what are the different issues that we're hitting. And we set a goal that no more than 5% of the errors that we report back should be non-actionable. So what non-actionable means is the developer can't do anything if they get an error that says, oh, my git clone failed. Like, what are you going to do? You're going to click retry anyway. So actionable means something like a compile error or a merge failure or like a lint error the developer actually can take an action on. And those are fine because those are valid errors. So we try to keep the non-actionable errors because of infrastructure or various other unknown reasons down to like the minimum we can. We of course have like an on-call as well as on our team to ensure that once we set these limits, if they ever go above the limit, we're there to ensure that we bring those back down again. This helps us make sure that the quality is always kept at the same bar. And this is very important if you care about the quality of your CI. Because if you fix it today and if it degrades later, then you start losing the trust again. Who likes flakiness here? I like them in croissants, but I don't know. I don't really like it in my CI. So flakiness is an issue I think a lot of us have to deal with. If you're working with CI, like not just CI, right? Like your tests can be flaky, your build can be flaky because of the Gradle daemon just quit for God knows what reason. Right? So we don't like flakiness. So what we do is like when we detect there's a flaky failure and it's something that is non-actionable, we automatically retry. We don't tell the developer. We retry a couple of times and check if we can get back a result. The same thing we do with tests. We retry, fail test a couple of times. And if they still fail, we do some action, but at least this mitigates the issue where the developer has to like know about the flakiness. We try to hide that away as much as possible. But one thing that we learned is like you have to like learn to embrace flakiness. Flakiness is going to exist in your system regardless of what you do. There's no such thing as like a perfect CI. I mean, if you have it, please talk to me afterwards. I'd like to know how that is. But generally, flakiness is something you'll have to deal with. So one of the strategies we use is like retries to like mitigate the impact that it has on the end developers. And flaky tests are like a constant nuisance, especially in a code base as big as Uber. We get a lot of flaky tests. And once they're flaking on master, it becomes the situation where master goes red again. So when I showed you folks the graph before, where we still had those blips in master where it's not green, it was because of flaky tests. And we would have some of these flaky tests, a lot more actually back in the day. Then what we started doing was we automatically started ignoring these tests and merged those changes immediately, and then we open a ticket on the developer saying, hey, this test is flaky. You need to go fix it. And even then, I don't think the developers actually ever fixed it. Has anyone ever tried like assigning like a bunch of tasks to developers to say, hey, go do code cleanup? Good luck with that. So they never really fixed it. So what we did was we started reminding them every week on the task that, hey, if you don't fix this test, we're going to delete it eventually because it's a waste of time. Keeping the ignore test in the code base, waste of build time, locally, both as well as on CI. We're not going to run that test anyway. Clearly, the developer doesn't care about the test. So after a month, we use like things like Java parser and stuff to like automatically figure out which code block it is, delete it from the code base, make a diff automatically, and then merge it again. And after that, it's gone. So if they didn't care, oh well. And talking about retries, we also keep track of like how many times we retry. So we don't want to retry too much because we put a strain on our resources. If you're retrying a lot, it means the infrastructure is actually not that stable. So we keep a cap on how much we retry on a weekly basis as well. And we want that to be like under 5% of all the changes that are being submitted. It's the same concept we follow with like a lot of our metrics in general. Let's talk about like Android CD. I guess not a lot of people got that joke. I want to talk about Android CD by going into a little bit of history of why CD is a thing. So CD in this respect talks about continuous delivery. We're not talking about continuous deployment. CD is so popular that it got like defined multiple times by multiple people. So in our case, we had this rider app retry about a year or so ago, where we had this one code base with the old rider app, and then we started fresh another repo with a completely new rider app. And the problem was we were shipping both apps at once in one app. There's like an interesting blog post going to be coming out soon on how we did that exactly. But general idea is that the entire app was packaged as a library, the old rider app, and then it was pulled into the new app. The problem with that was the repos were using different versions of libraries, and anytime there was a change in the old app or the new app, they could break the other one. And that was not great because we would get like issues, we would get cross repo master read issues. It's kind of hard to explain. But we just didn't want the final merged app to have any issues. So to kind of combat this, we thought, okay, what if we on any commit in the old app, what if we pushed like a AAR to like our artifactory or whatever, and we just try to build the new app along with the old app. Let's just see if it compiles and like there's like no issues with at runtime or whatever. So that's kind of how we set up our ad hoc CD, and that's kind of how we thought, hey, this actually is kind of cool. So we detected like a lot of issues doing it this way since we were in like multiple repos. But after that, we migrated everything into one repo, so that problem is no longer a big concern. But in general, at that point of time, it was really useful to have a system like this. So once we had that, we decided to kind of adopt this in the other apps that we have in the mono repo. So at the end of submit queue, once you go to the code repo, we actually now also have a post commit hook that triggers the continuous delivery job. This is not super complicated. It just figures out what apps were touched in that commit, and then calls our CD service and says, hey, go build these apps. The CD service then kicks off another CI job that builds these changed apps, and then pushes them to a service called Metro, which is kind of like our service which keeps track of all the APKs that are coming in at every SHA. So this is how we kind of like solved CD. This is very invisible to developers for the most part, but we do comment back on the chain saying, hey, like a build is available, like a release build with full ProGuard and all sorts of transforms or any sort of post-processing that we run that you can test. And we comment back on the change, and we also have like a small app internally that lets you download the changes that you just merged, essentially. There is a delay between when you merge the change and when you can actually download it. But this is going to give you the exact same APK as if it were something you would ship to the Play Store. There's no signing key differences or anything. Just the package ID is different, so you can have it side by side with your production app. And this will let us have developers do more continuous testing on the final release APK rather than doing it on debug and then figuring out that later it was broken on release. Of course, we had to like do some optimizations along the way to like make this possible. Like we couldn't really run like a full ProGuard optimization pass, so we had to like change our config to make it possible to run in like a reasonable amount of time. So like we have metrics on the CD builds as well that we track to ensure that they don't go over like a reasonable amount of time. I think currently we hope everything should be building under like 1 hour. We're actually well below the 1 hour mark. So you do get builds rather quickly once you merge something that you can actually test out. And that's how we kind of have our CD setup. We haven't like done much into like continuous deployment yet, but that's not something people tend to do in mobile unless you're doing like cross-platform stuff like code push or something. So for the native side of things, continuous delivery is like a good enough option. Now our release schedule was a lot more on time because we would detect issues like pretty much on the same day or like within the same hour once the change got merged. All right. I talked a lot about what we do, so I'm going to spend a little bit of time trying to explain how you can kind of do stuff that we do in your own code base or your own CI. Right? You may not all be using Buck, so if you are using Buck though, like please come talk to me after. I'll be happy to share how we do this stuff in Buck with all the log parsing and stuff. But if you are using Gradle, for example, how would you do this? Right? So there is a small snippet that we use for all our Gradle error interception. So like you can intercept all the errors that Gradle outputs at the end of the log using like a small Gradle file. There's a gist at the bottom if you want to like kind of copy paste it into your code base. So you can put this in your root build.gradle file at the bottom, and it just registers the listener that listens to like the standard error output of Gradle. So anything that's captured in the standard error is captured in, for example, like a log file. And you can get creative. You can do things like parsing the logs, do some regex, whatever suits your needs. But at least you can just comment back on, let's say, your CI system with the final output of Gradle rather than you having to go to the Jenkins or whatever CI link to figure out what the error was. So this is kind of still useful for intercepting Gradle errors. Similarly, for test logging, Gradle actually provides like a really good API for controlling the different test events that you get on the console. This is just an example, like don't read too much into that, but this is a link to the test logging container. You can customize like what you get on the console. You can kind of trim it down to the stuff that you actually care about, and you just play with the settings. So like figure out what works best for your use case, and then you can post back the same thing, or again, like you can do parsing of this stuff and make like a pretty report, or you can like even upload it somewhere if you wanted. But this lets you like do the stuff that you're doing with logging, like the test logging, very similar fashion. And you can also potentially detect like hanging tests because you can see when the test started based on their timestamps, and then see if your build is finished, but then the test didn't actually finish. So you could do the same thing that we do as well. So how do you actually report this stuff in line, right? So that is, I think, the most interesting thing here. So GitHub, for example, has this API called the Checks API that they put in beta in May of this year. It's not fully rolled out yet, but the beta is open to a lot of like open source projects as well. So I put links to like the GitHub integration. GitLab picked it up afterward as well. They support the same exact API that you can use to like report back static analysis or compilation errors, whatever flows your board, back onto your TRs, for example. There's also like a nifty library called violationslib that does automatic parsing of static analysis, like error-prone, Android, lint, checkstyle, PMD, and a bunch of other tools. It just also integrates with like GitHub and GitLab as well, so you could pretty much use it out of the box for like a bunch of stuff, and you can always customize it to like report more things if you want it. Also, like talking about like what you can do in practice, I think it's really important to note that you should definitely measure if you care about your CI experience. A lot of times, like you might make improvements that will last for a bit, but if you don't know how you're changing or moving the needle, it's really tough to justify the time you're spending on CI to like your management, for example. So for Gradle, you can use things like Gradle build scans or the Gradle profiler to get like a report that you can use to like keep track of your build history over time as your code base evolves. And if you can, like definitely measure like other things. Like if there's a failure in cloning the Git repo, for example, try to send up a metric because that tells you how stable your infrastructure is. It might be time to like invest in like a larger disk or like a better networking pipe, but you won't know until you measure. So that's something that's really important to do early on. And then enforce. So once you have all this stuff laid out, it's really important that you put guardrails in place so you don't go off the track again. If you don't enforce and have like some sort of like a promise to your developers that says, hey, our build time limits are going to be this. In case they go down, here's what we're going to do, but at least we know about it rather than you coming to us and telling us about it. It's really important to do that. So if you can enforce things, people will trust your CI more just because they know that you're watching over these things constantly. So definitely enforce whatever you can. If you have like internal dashboards or something, if you look at them every day, or even just look at build scans, right? You can just take a cursory look over them, ensure that, okay, it still looks good. But it is like a full-time job if you do all this stuff, so kind of like pick and choose what makes sense like most to you. Like if you care a lot more about like just the inline reporting, that might be good enough. You don't really care about build speed. I don't think I've met anyone who doesn't care about build speed, but try to like see what makes sense to you more than anything else. And with that, that's the end of my talk, and we have a few minutes for questions.